see. Um, okay. So for the day, we have to discuss the unsupervised learning. See, so many supervised processes we had seen. Okay. Uh, Now we need to understand the unsupervised learning. Right. So it's a learning process where you know we use the unlabeled data. Right. Here data is not labeled. It used to be unlabeled. That means we have the features given, right? But according to the problem statement, the labels are not given. That means what happened at the end, what those features are representing, that is not given, right? So here we have to do what? We have to label the unlabeled data. Okay, we have to label the unlabeled data. That is a process we have to follow over here, right? So now question is, how can we label the unlabeled data? There is a very simple way to do this thing, right? So what we do, let's say if I have the data given like this, okay, like this, right? So what we need to do, we need to find out that what are the different groups that may exist over here, right? So there are certain statistical process that I'll tell you. Using those statistical process, we have to find out what are the different possible groups that may present over here, right? And we just kind of form those groups, and this is called what? Clustering. Okay, this is called what? Clustering. So in unsupervised learning, mainly we use two processes. One is called clustering, okay, and second is called association rule mining. Okay, association rule mining. Right. So now clustering can also be used for anomaly detection. Anomaly detection, that means something which is not normal, right? And association rule mining can be used for what? For recommendation system. Okay, like just to build a system which can be used to recommend a product, recommend a movie, those kind of things. So we'll work on both of these things, clustering and association rule mining, right? PCA is also there, which is a part of unsupervised learning. PCA stands for principal component analysis. Okay, this is used to reduce the feature size, so that also I'll try to discuss with you. But first let's start with the clustering part. Okay, so for the clustering, let's see, I just define some data over here. Okay, so let's say I'll define some random kind of data, nt dot random integer. Let's say I define it between 10 to 40. The sample size, let's say 6 cross 2. NP is not defined, right? Import numpy as NP. Okay, and then this is one of the matrix. Similar to it, I'll define two more matrices. And here I'll give it a value, let's say 35 to 75, let's say. And then I'll again define something, let's say 65 to something like 100. All right. Let's say 70 to 100. All right. Now I'll do what? I'll just make this thing into a one matrix. NP dot vertical stack VSTACK, vertical stack. Okay. Vertically, I'm trying to stack these three things. What happened? This is done. This is done. What is showing error over here? On extra bracket, I guess, right? Sorry, let me just check it once. This one, this one, and this one. All right. Now, all right. Number dot incomplete input. Why is it showing error? It's what happened? Let me check. As per my understanding, it seems to be correct, right? The vertically stack. This one is also correct. There in the code, this because VStack function call is missing a closing parenthesis. I don't know where it is. Was I missing one bracket? Yeah, fine. I may be missing one bracket. Yeah, it's okay. So this one is this one and this one is over here. Okay, fine. So maybe I was missing some bracket over here. Anyway, so here I just have a kind of a matrix, right? And I will put it into, let's say, N1. Okay. Why I did it, I'll tell you. First of all, let me just do this thing. So let's say I have this particular data, right? And here the data is not labeled. What I mean, for these data, it is not mentioned that which sample belongs to which particular target. Okay, there is nothing mentioned. Okay, it is not mentioned that okay, the first sample is representing what, second sample is representing what, third sample is representing what, right? It is not mentioned that it is category A, it is category B, it is category C. Nothing is mentioned, just we have a feature, right? So let me put it into data one. Okay, and I'll give it a column name as, let's say, columns is equals to, let's say, x1 and x2. All right, here are the columns we have. Right, now let's call d1. Fine. Now I have to understand the clustering concept over here, that how actually clustering happens, isn't it? So for the purpose, first of all, let's try to plot this guy. Import. So for the plotting, which library we use? Matplotlib, right? So import matplotlib dot pyplot as plt dot scatter. We have a data over here called d1 dot x1 comma d1 dot x2, and then so. Right. So this is what we have. Right. Now I want a mechanism which can identify the similar items. Okay, which can identify the groups. This is one group. This can be other group. This is other group. So there is some formula that I want. There is some process I want that could identify these groups. Okay, and separate this whole data into three groups. Right. That means this whole data can be converted into three clusters. Okay, we can create three clusters out of this data. So how can we create those clusters? That's what we have to understand over here. All right. So we start with a process called over here. Here, the step one. Define centroids. Again. Now, how many centroids? That would be equals to number of clusters. That means if I have to form three clusters, I have to define three centroids, right? So let's say centroid 1 is equals to np dot random dot random integer. Okay. So what should be the value of centroid? The value of centroid should be within these x and y coordinates. What is the minimum value of x that we have? We have 10, and maximum we have is 100, right? So I'll just take over here between 10 and 100. And we have over here two coordinates, right? So that's why I also required one more. I'll tell you the relevancy of it, like why are we doing it, right? It is very relevant thing, right? So now let me just call this plotting thing over here, paste it over here and plot the centroid. What is the value of centroid we have? Let's check. It is 58 and 57, right? So I'll just call it here plt dot scatter centroid 1 index 0 comma centroid 1 index 1. Okay. So the point you can see over here, this is what we have defined. Okay, we can make it, let's say marker is equals to asterisk and then color is equals to red. Right. Now the point is why we created it, and this is totally defined randomly. Randomly defined means what? If I execute this thing once again, it will change its place. Right? If I execute this thing once again, it will change its place. Okay, you can see. It is just changing its place. Right. So what are we doing? See, first of all, I have a data. This data is having a behavior like it is having three groups, okay, three clusters. I just need a mechanism to find out all these three clusters or the members of these three clusters. I have to find out a mechanism through which I can find out the members of all these three clusters, right? So for the purpose, we did what? We first defined centroid. How many centroid? As of now, just one centroid. But we required three centroids, right? So let's copy this thing. Okay. So I'm taking any random value between 10 and 100 to define three centroids over. Why three centroids? Because I required three clusters. Centroid 2 and centroid 3. So this is your first centroid, red. Let me define green and blue. Centroid 2 and centroid 3. Red, green, and blue. Okay. So these are our three centroids, red, green, blue, that you can see over here. All right. All right. So now, if I have to form the cluster, so what should we do? See, initially we have to find out for any particular data point which is closest. Like for this data point, which is closest, red, green, or blue? Seems to be blue is closest. So it will form a cluster. It will form a cluster with blue centroid, right? Same way, let's say for this data point, which is closest. It seems like red is closest. As red is closest, so it will form a cluster with red point. Right? So each data point will find out which is closest from it. Like from here, green is closest, so it will form a cluster with green color. Right. That means each and every data point will find the closest centroid from it. Why it will find out the closest centroid from it? So that it can decide in which group it can go. Right? It will go to that group which is having it will form a group of the group with that centroid which is closest to it. Right? That means now I have to do what? I have a centroid over here. Okay, and then I have a over here data that already I have D1. Okay, so from this thing I'll subtract the centroid. Okay, centroid index 0. All right. So what is your distance formula? If I have 2 points in a coordinate system, right, and I have to find out the distance between those guys. Okay, let's say here is a point called x1 and x2 or x1 and y1. Here is a point called x2 and y2, and I have to find out the nearest distance between these 2 points, right? So what should I do? Let's say, this is what? This is y1 minus y2. This is x2 minus x1. So this will be minus x1 whole square plus y1 minus y2 whole square, right?
Yes, sir.
Okay. So same formula will be implemented over here. I have to do what? Just take this thing, square of it, plus d1 dot x2. Okay. x2. This is your x2 column. Right. Minus the second coordinate in the centroid. What is second coordinate?
Centroid 1.
Right. Coordinate 1. Centroid 1, coordinate 0. And then I have to take the square root of it. Right. So this is called the distance from the red color. So D1.
So for
Red
the second part, I think square is not also. Like D1 x2 minus.
Right. So this is a distance from the red color. Same way I can calculate distance from green and blue. Right. So distance from green and distance from blue. Right. So this will be represented by D1. This is centroid 2. Right. And this one is centroid 3. This one is again centroid 2. This is centroid 3. Okay, then I have D1. Okay, so I have the distances. Right. Now I have to find out which one is closest from each data point. Like for the first, here green, for the second, again green, for the third, again green, here again green, here again green, it is also green, it is red, this is red, this is also red, this is also red. Do you have blue or not? Yeah, blue is also there. Okay, this is nearest, right? Blue is lesser, but yeah, blue is there. Right. So a few data points closest from red, few from green, few from blue. So now what we do? We'll pick these columns D1, red, green, and blue. Okay. And we'll try to find out which one is closest. So dot minimum. But it has given me the minimum value from the column. I want from the row. So axis is equals to 1. So minimum from the row. But I want the row header. Sorry, column header. Like it is minimum, but it is red, green, or blue. This is green, right? So I will use IDX minimum. So I'll get the exact thing, right? So now this value I can assign as a label into the data sample. So now let's check D1. We have red, green, and blue, right? So now I'll try to plot it. Okay, and here I'll give it a label like say color is equals to D1 dot label. Right, so this is your initial cluster. So what are the steps we followed? I'll share this file with you and thereafter I'll explain once again. It is not completed, but we'll complete it very soon. All right. So what we did, first of all, we were having a data like this, randomly generated data, right? So we can plot it. It seems to be like this. Last time it was different. This time it is different because it is a randomly I'm generating the data. I'm generating randomly, but I should not generate it every time. I should keep it fixed, right? Now what I did, I need to form 3 clusters. So I defined 3 centroids. Okay, these 3 centroids are looking like this, right? Now from each centroid, I am calculating the distance of the data points. Okay, like this particular for each data point over here. Like for this data point, what is the distance from red, green, and blue? For this data point, red, green, blue. For this data point, red, green, blue. For this, that means that's what we are calculating. Stored it into a data table like this. Then finding out which one is nearest, right? And that information we stored in a label column. Okay, and then based on that information, we are plotting and giving it a color. This is first step done. Okay, so now next step will be what? Next step will be updating the centroid. How do we update the centroid? What we do? We'll take the average, like the average of all the green color points. That will be the new centroid. Okay, so that may exist somewhere over here. Okay, average of all blue color point, that would be the new centroid, that is blue centroid. And average of all lead color point will be a new centroid. That means here d1 dot group by based on what? Based on your label column. All right, we'll take over here. X1 and X2, and then we take the mean of it. Right. So this is going to be your new centroid. Okay. I'll do what? I'll just convert this thing into a matrix. Okay. And we'll unpack it into centroid 1, centroid 2, and centroid 3. Right. So now I have over here 3 centroids, which is just the average of each cluster. Right. Now I'll try to plot it. So this is your new centroid. Okay. Based on these new centroids, if you will try to again find out or redefine the cluster, obviously the clusters will change. The members in each cluster will change. Okay. Few red points may turn into blue, few green point may turn into red, right? So many things are going to happen. That means based on this new, see, centroid changes their position. Green was over here, green came over here, okay? Red was over here, red just moved that side, blue came over here, right? That means now, again, if I do, follow the same mechanism, the distance is, this is your distances, and based on the distances, find out the minimum. So here we are finding out the minimum for the labels. Based on the distances, finding out the minimum for the labels and define the labels. And based on these labels, again, let's try to check what changes happened. So if you see over here, what change happened? These turned out to be blue, right? And we have, these are the red points. Okay. Now next, what will happen? Again, there will be a update. That means again, we'll try to calculate the distances, like the average. So again, this thing will happen, the average will happen. So this is the average of each clusters. Based on this average, if I try to plot it, let's try to plot the new centroids. So this will be your new centroid, right? And based on this centroid, again the members will change, right? So let's change the members. This is an iterative process actually. Okay. And then again plot it. All right. So as of now the same process will happen. This one, like let's say again update the centroid. Centroid gets updated. Based on the updated centroid, so it is almost stable. These are the three groups it identified. Okay, it identified these three groups over here, right? So it may here, because of the positioning centroid, it just identified these three groups, but there can be this three group can also be there. Okay, like in case if you find that no, it is not identifying the groups correctly, this there can be this group, three groups can also be there, right? But it has identified these three groups as of now, right? So in case if we find that no, these are not identifying the groups, why I say that these three groups are identified, because after this, if I try to update, the things may not change. Once it is stabilized, I am trying to again modify it, nothing is changing. But since it is unsupervised, okay, there is nothing to evaluate. We can only statistically try to define the groups with the help of centroids. Okay, with the help of centroids, we can just try to explain it. Okay, that this is centroid 0, red color. It is representing the average value of cluster 0 or cluster or the first cluster, average value of second cluster, and average value of third cluster. Right. So what we can do over here, this is red, this is green, this is blue. So blue is maximum, green is minimum. So now this is the first cluster that we form. Okay, many a time, there is a more better version of cluster may possible. So we can again re-execute the whole process once again. Let's say we are defining the centroids over here. Okay, so let's define the centroid once again. Okay, first of all, let's say this is our centroid. Okay, based on these centroids, again do the same thing. So this is your initial cluster, right? Then find out the groups average of red, green, and blue. Based on the average of red, green, blue, this is your new centroid. Okay, this is average of red, green, and blue. Something I am doing red average. How red average over here? Centroid 1. Red average, which coming over here. I am little. How is it possible that red average is over here? Anyway, let me just check. Now it's fine. Okay, it was earlier over there. Okay, so now you can see after this, if I try to re-execute it, it is now stabilized. Okay, so as it is stabilized, we can just decide that okay, these are the three clusters we have. You can keep executing after it will not change. So everything is started randomly, right? We just define the clusters randomly, red, green, blue, and with the iterative process, again iterating, finding out the average of each clusters, then again iterate, then again find out the average of each cluster, then update the centroid, then again find out the average of each cluster, then update the centroid. At the end, you will have the clusters, and the cluster centers is representing the is representing what each clusters actually mean over here, right? This is called what K-means clustering process. What this process is called? This process is called K-means clustering. But since it is unsupervised, we can't evaluate it. Okay, we can just form the clusters and statistically try to understand whether that cluster is having some relevant information or not, right? Just go through the things. Thereafter, I'll tell you how to use a library for it. Then, shall we go ahead?
Yes, sir.
Mhm. All right. So let's say I'll take this data. Actually, I updated the D1 only. I should not update D1 so that I can take the same data. Anyway, let me just do one thing. Just define over here. D2 is equals to D1 dot copy to be used later on, right? Okay, so this is the data. Centroid. Red, green, blue is over here. Red, green, blue. Based on this red, green, blue distances, labels, we have there is no red being present. Okay, so let me just try to recreate the centroid because red went very extreme. I have Well, again red is not there. Something I'm doing, I guess. Red, green, blue. Just a minute. This is centroid. Red, green, and blue we have. Just a minute. Okay. Based on this, I am calculating the distances. But why this guy came over here? Let me define the data once again. Define the centroids. Red, green, and blue we have. That is fine. Now I'll calculate the minimum. We have all blue. Why don't we getting red? Because red is extreme, right? So let's try to avoid extreme. For avoiding the extreme, I'll take over here between 20 and 90. Because sometimes it is going at extreme. So it is not getting any point. All right. Red, green, and blue. All right. Then okay, now I get one red and few green and few blue. Now based on this, if I do it, this is something. So now the average of blue will be the blue centroid, average of green will be the green centroid, and average of red will be the red centroid. So this is average. So this is your new centroids. Some color, I guess I'm doing incorrect. Centroid 1, centroid 2, centroid. Here I am giving red, but this should be blue, right? Green is fine, and it should be red, right? Where it should be red, the color it is getting blue. So some color things I'm doing wrong. If I'm doing it wrong, centroid 1, 2, 3, that is fine. Centroid 1, centroid 2, and centroid 3. That is good. Like I'm doing it correct over here. So color thing it is getting the representation is somewhat wrong, I guess. Centroid 1, 2, 3, 20, 90. Okay, let me just try to reveal. We have this one, then we have three centroids defined. Okay, then the first centroid I had given a color red, second is green, and third is blue. Then I'm grouping it. Right. So here grouping is something, when I'm grouping this guy, where I grouped it, right, this one distance. This grouping, most probably when I'm grouping it, now it is putting the things into alphabetical order or something. That's why I'm not getting the correct in notation over here. Anyway, let me check. Dot. Yes, you can see it is BGR. So as it is a BGR, then this should be 3. Okay, because red is what? Red is 1, right? So red is 1, and this is what? 3. Okay,
So
so that
whether group Y actually even orders it by alphabetical order.
alphabetical order. Yeah, right, right. It is ordering in the alphabetical order.
Okay.
Yeah, that's the reason, the color is over here creating a problem. Now it's fine. So we have this one blue one, this is green one, this is red one. Now I have to find out the distance from each of them. So this is your distance, and based on the distance, if I'll check the next thing, so you can see these all becomes red, these all becomes green, and these all becomes blue, right? And then again updating the centroids. So this is 3, this is 1. Okay, now let's plot it. Now this is updated centroid. Obviously now it is stabilized. So as it is stabilized, then it will not make any major change, right? And then I can have this thing. Right. And these centroids will just represent my clusters. Okay, what each clusters means, right? Now let's try to use K-means libraries for clustering. Okay. So let's say I have d2 dot head. Right. This is your d2. It is just copy of d1. Right. So plt dot scatter d2 dot x1 comma d2 dot x2. All right. Done. Now I'll do what? I'll just take the library from sklearn.cluster, import KMeans, and then model KMeans is equals to, just define KMeans over here and define number of clusters is equals to, let's say 3. Then model underscore KMeans dot fit d2. All right. Before doing this, one more thing that I'll do over here, I just get d3 is equals to d2 dot copy, so that in case if I have to use it further, I can use it. Right. So once it fit, it will identify the clusters for each data point. Right. So I can just do the prediction over here d2. Sorry, d2. So it is a predicted value, and this predicted value I can store in the d2. That means it labels the unlabeled data. Okay, labels the unlabeled data, right? Now d2 dot head or d2 let me call. So here I got the labels of unlabeled data. Right now, what each of these clusters means that I can identify by checking the cluster center. So d2 dot cluster underscore centers. Sorry, I guess I have to use model, not this one. Model K-means. So now we have the cluster centers, right? This cluster center, for the better representation, I can use convert it to data frame. Okay, and where each column can get a value as x1 and x2. Okay, so this is your data. Okay, so this is your cluster. Right, I can just analyze it visually by using dot plot dot bar. So I have this information where cluster 0 is having that group of data where x1 and x2 both are higher in the higher range. Okay, cluster 1 is that group of data where they are list, and cluster 2 is that group of data where they are in the intermediate level. So all these clusters are having 3 different behaviors, right? So it's very simple, just 3-4 lines of code, right? Now based on it, I'm giving you an assignment that you work upon. Right now you'll work upon, just a minute. You have already the data. I'll just you already have the code. I'm giving a very simple assignment to work upon. Okay. Small customer pd.read underscore csv. Okay, so let's say this is our data. In this, we have a customer ID, we have a gender, we have an age, annual income, and a spending scope, right? So let me write the problem statement over here. It is a data representing the representing some information about customers visiting a store, right? So what you have to do, find out or perform clustering based on different behavioral pattern in the data, right? Hint, use age, right? So these three columns you have to use and you have to form the clusters. And at the end, you have to explain the relevance of each clusters using the in the cluster centers or centroid. So please try to do this thing. It will take you hardly 5-7 minutes or 10 minutes, let it be. But please try. Once you did it, thereafter I will do from my end. Okay, just to in case if you do some errors and all, so it will help you to understand better. So first, please do try. Take 10 minutes of time and please try to do it and finish it. File is already there with you. You will just refresh that. You did it. Whatever the result you are getting, please share with me. I just want to check your approach.
Sir, it can be three-dimensional graph as well, sir. I was just curious. Like,
Yeah, it can be. Okay, see, here you can assume like that. Over here it can be a like this, right? You are saying that one can be your
yes, sir.
age, other can be your income, other can be, yeah, fine. That is possible, right? We can just do the graphical things like that. But what if it is, kind of a, I have 4 features, I have 10 features, then anyhow I can't plot a 4 dimension graph, right?
Yes, sir.
Right. So the point over here is we have to think some other solution, right? So that that can be used with any number of features, right? So let's see. First of all, pick those columns that we are targeting. Okay. Right. And one of the most simplest approach to identify the number of clusters is what we can just do over here, a pair plot. So pair plot can do what? Can actually give you an intuition even if you are working with any number of feature size. Okay. That how many clusters can be good. So out of looking all these plots, we can see that this particular plot is creating a you know, five clusters, right? If I consider spendings and income, but this is not having the information about, this is considering
Wait,
spending and income only. Age information is not there, or even because, let's say if I have a data like this, okay, this is income, this is spending, this is age, right? Now let's say I have the information is present over here like this. All right. So now, if I look at in two-dimensional space, then this will show me what? Only three clusters, right? Two-dimensional space is what? It's a three clusters.
yes.
But in three-dimensional space, it is having what? Four clusters. In three dimension, it is having four clusters, but in two dimension, these two things will be visible one in two-dimensional space, right?
Yes, sir. It will be squeezed to one like on.
Right. So, so what are the challenges? First of all, if you have more than three features, you can't decide by visualization. That is one problem. Second thing, if you have, somehow if you are visualizing it, then also, it may be misleading, right? You may not get the actual number of clusters. Even with this kind of a clear plot also, it is not very much evident that whether it should be 5, whether it should be 6, or whether it should be 7, or whether it should be 10. Because it may possible, here it is looking 5, but when you go to the three dimension, it may be 10, right? So that's why, to find out the possible number of clusters, there is a process that we use that is called elbow method. Now, what is elbow method? This is used to decide optimum number of clusters. All right. So let's say I have over here D2. Okay. Let's say D3. Okay. So let's say this is D3, right? So this is just a copy of D2, and D2 was the copy of D1. Okay. So here I have to decide how many clusters can be formed. So since it is two dimension, it is very easy because we can just plot it like this and can decide. But still, what is elbow method? That's what we have to understand, right? So what we do over here, we'll just define first model K is equals to K-means, and here number of clusters is equals to I. Now what is I? That means we are going to create a loop and the value of I will change from it. So for I in range, let's say 13, at least number of clusters should be 1. So I should use 1 over here. Then model K dot fit for D1, or let's say D3. And then we will calculate something over here, which is called inertia. I'll show you what is inertia. All right. So if you see over here, what value you can see? The initial value of this inertia when the number of cluster is equals to 1, it is 26,069. When number of clusters becomes 2, this becomes 7,975. That's a big change, right? But from here onwards, you can see the changes are very small, right? Here, almost 80% now. Here, almost 50, more than 50% now. Okay, the kind of thing, right? So the thing is, the value changes initially very drastically, but after that, it is not changing that drastically. What is inertia? See, when you have the data present like this, okay, okay. So when I decide that I have to form a single cluster, the value of I is 1. That means there will be a single cluster with single, that means I'll have overall one centroid, right? And the centroid will have a certain distance from all the data points. Okay. So when we calculate the cumulative sum of all the distances, okay, that is representing my first inertia point, first inertia value. Okay. Next step, what we do? We will form two clusters. Okay, because here the value of I will become 2. So let's say this is 2 cluster. So we have 2 centroids. So this will be the distance from this centroid and these will be the distance from this centroid. Obviously, these are lesser compared to the previous one because they came more closer to the data points. So it calculate and sum it up, so it will be lesser. Next step, we'll form 3 clusters. Okay, so 3 clusters will be like this. Okay, so now they are more closer to the data points, so it will be more lesser. But when we start forming the number of clusters more than it is required, that means 3 clusters, and then we are forming 4, 5, 6, 7, 10. Okay, then the distance, this will not change significantly. That's why when you will store all these things into a list, let's say make it a list called losses, and in this losses what I do, I'll append it. What I'll append? I'll append this inertia value, and thereafter I'll plot it. Plt dot plot range 1 to 13 and then losses. All right, and here marker is equals to asterisk. So you can see a elbow over here, right? So this elbow will is something which is at 3, right? And how many optimum clusters were there in the data? 3. So whenever you apply a elbow method, with the elbow method we get a general idea that okay, how many clusters can be good, right? So this is called what? Elbow method. So we applied it on the D3, right? Now similar to it, please try to apply the elbow method on this data, that is your mall, the DF1, and let me know that how many clusters can be good. 2, 3, 4, 5, 6, 7, whatever. So what you have to do? You have to apply the elbow method to decide optimum number of clusters. This is what you have to do. Please try to do it and check it out. I already did it. I want you to try this thing because if you will do it, you'll never forget the things. What do you find? How many clusters can be put over here?
So I actually see 5 clusters.
Mm-hmm. Okay.
The graph from 5, it's like coming parallel to the x-axis.
Hmm. Five clusters you are getting. Let me check. Okay. So just a minute. Okay. So here I have DF1. So as per I just define over your model, small, that would be equals to KMeans. Okay, number of clusters is equals to, let's say, I, right? So now for I in range 1 comma, let's say 13, 14, anything I can define. Right? And then I have to just fit the data. Right. So model small dot fit df1. Okay. And then I'll calculate the inertia. So losses is equals to a blank list model dot inertia, and I'll store into losses. And then I can just plot it. So plt dot plot range 1 to 14 comma losses, and then plt dot soup. All right, so I'll just give a marker also so that I can better recognize it. So marker shows that 5 or 6. Yeah, 5 or 6 can be a good choice. Okay, it is 1, 2, 3, 4, 5, 6. Yeah. Second, now it is forming better. Okay, so now I don't know like why earlier it was not good. Maybe some problem. 1, 2, 3, 4, 5, 6. So 6 can be a good choice over here. Forming a elbow over here, right? So now let's try to form the clusters. So model um, A is equals to K means number of clusters is equals to 6. Then model A dot fit df1. Now I have to explain each cluster, so I'll calculate those cluster centers. Okay, so when I calculate the cluster centers, I have 6 clusters, so 6 cluster centers are there. Right, we can convert this thing into data frame.
So your voice is breaking.
Okay, so here let me check my internet. It's fine, I guess.
So now it's okay. So actually it break for some like few seconds.
All right, no problem. All right, fine. Okay, so here we have the 6 clusters formed. Why? Because the elbow is showing 6 is the optimum value. Then when we fit the data, it forms the 6 cluster out of your data, and then we can just have the cluster centers. There are 6 cluster centers that we are converting into data frame, and I can give the column names as df1 dot columns. Okay, so this is my cluster center, so I can say that df, or you can say mall or customers. Let's say this is my customers, right? Now we can do what? We can just try to plot it to understand the behavior better. Dot plot dot bar. So we can say that we have there is a group called cluster 0 where age people are of higher age but they are having the lesser income. So this people of age more than 40. Okay, people of age more than 40, we have 2 clusters, I guess, or 3 clusters. Okay, people of age more than 40, we have 3 clusters, right? The first cluster in which income and spending score is lesser. Second cluster is something where income is very high but very less spending score, and here it is up to intermediate level. So these are the group of person who are spending very less. So we can propose some investment plan, some kind of we can just reach out to them because they may have saved a lot of money, right? These are the people who are earning and spending both high, so they credit card can be given to them. Okay, offer related to credit cards, right? Now talk about those guys whose age is lesser than 40. So age lesser than 40, we have this group, okay, whose earning and expense are high, right? This group whose also earning and expense are maximum. This is next level. This is maximum. This is next to it, right? And here we have a group which is very different, whose expense is very high. Out of all these groups, this is a group whose expense is very high compared to their income, right? So this can be anomaly as well, or we can just check like what are the reason behind it. But anyway, we identified 6 groups having the 6 kind of behavior. Right. So now I want to find out, or I want to assign the labels. So how can we assign the labels? Assign the labels. So model A dot predict. What I can predict? DF1. So these are the labels 0 to 5 that I can assign it to DF1 or DF. df labels. So df dot head. So now, if I have to identify that group whose expenses are very high compared to their income, that means I have to find out label 5. So df labels double equals to 5. All right. Let me know if you have any doubts. Anything you want me to explain over here?
So can we describe the labels like, like just whose group is five, their age is between this and this, and their annual income is this and this, and then their spending score
Yeah,
is.
correct. So for describing the label, only this cluster centers we identified, right? The purpose
So
of this cluster. Mhm.
I mean like instead of 1, 2, 3, 4, 5, like you can
One,
even
two, three. Mhm.
yeah, the six clusters. Sorry, 0, 1, 2, 3, 4, 5.
Mhm.
Like we can change the name of the label like by knowing the described feature, like the minimum age of this group one is this, and the maximum age is this, and minimum of annual income is this, and maximum is this. Like it would be, I thought maybe it will be more.
Definitely, definitely. You can see once you label it, right? So thereafter, what you can do, you can just take df dot group by, okay, group by, right? And you can just take the labels column, right? And then you can
Yes,
take the column that you want to aggregate, like say you want to aggregate these three columns, right?
yes,
So we can just take these three columns, all right? Okay. Dot aggregate and whatever, let's say minimum, maximum, and mean, right? So I have the information about each labels, minimum, maximum, and these things, right? So this is for the age, this is for annual income, this is spending score. In case if you want to keep it separate, you can just keep it separate as well, right? I just put them all together, isn't it?
yes,
Yeah.
got it.
So mhm. You can do what if you're if you can keep it separate, then I guess it would be more informative, I guess. Okay, and then I can plot it. So these are the three groups where minimum and maximum age and average age, right? So same way we can do it for the income and other things. All right. So based on it, I'm giving you one more case study to work upon. Let's try that. Now we have multiple features. Okay, we have 1, 2, 3, 4. So what is your problem statement over here? Let me just show you the problem statement as well. This is a problem statement. There is an NGO who is having some $10 million of fund, right? And they want it to use in those countries where these funds can help people, right? So they have the information about different country like this, child mortality, exports, imports, and different things, right? So you have to find out those groups of country where this fund should be not I should say invested. This fund should be used, okay, for the betterment of majority of the population, right? So for that purpose, what you will do, because it is unlabeled, it is not labeled that which country requires the fund. So can you just think of it? What should we do over here? Just try to first work on it and let me know how many clusters can be good over here. Just a minute, I'll share my screen. Meanwhile, just try to finish that. You got an idea?
Yes, sir.
Okay. So how many clusters do you think?
Sir, actually, I was doing it, so sorry for taking time.
Mhm.
I kind of got the idea, like the one with less child. I mean, more child mortality. I mean, that's related to child death, I believe, right?
That can be one thing, but yeah, we have to consider all the given features. Okay, so let's see. Here we have first we'll take in the columns that we want to use. So let's say DFC1 is equals to DFC dot drop. The name of country we can't use for the calculation. So first of all, we'll drop it. So this is columns is equals to country. All right. So now DFC1 dot head. So these are the things. Now I have to do what? I have to understand how clustering works over here, right? So first I have to apply a elbow method. All right. So elbow method will be like this. Define a model. Let's say model for the country I use CT is equals to KMeans. Number of clusters is equals to I. Let's say K. Right. So now we can just run a loop for K in range 1 to let's say 14. Okay. Then model CD dot fit DFC1. Okay. Right. And then I can calculate model CT dot inertia. Right. And this I can store over here losses. All right. So losses dot append in this thing. All right. Now let's calculate over here PLT dot plot. X-axis can be range, that is 1 to 14, and y-axis can be the losses, that is your inertia value. PLT dot show. Okay. And then I can have the marker. So marker can be equals to asterisk sign. Okay. So it shows that 3 or 4 can be a good choice. Okay. Here, if I'll consider this data DFC1, here DFC1, right? So 3 or 4 can be a good choice. okay, which can help me identify the, because after 4 it is almost horizontal, right? So this is one of the way of deciding the clusters, say like how many clusters is good. Or there is one more way of deciding the cluster, that is called silhouette score. Okay, silhouette score. Okay, so apart from this thing that your elbow method, silhouette score also, if you have a confusion, you can just take, try to see like what is silhouette score. Silhouette score will also something which will, kind of change for each number of cluster. What is the formula of silhouette score? Silhouette scores in clustering. Right. So first see the definition. See, it just try to compare if I have two clusters, right? Okay, I'll give you the high level understanding. Thereafter, I'll show you the definition, right? Let's say I have two clusters. This is cluster one and this is cluster two, right? Select this. Okay, let's see. And we have the data points over here and some data points over here, right? Now what happened? It will just try to calculate, let's say for this point, okay? For this point, these distances will be calculated with the other data points, right? And we can take the average of it or sum of it. And thereafter, we'll also calculate the distance from here to other cluster. All right. Right. And then we try to take the average of these two entities. That means sum of it and sum of it. Let's say D1, D2, D1 upon D2. Right. So if this value is lesser, right? If this value, if I take the average of it, so let's say this value is, it's in own cluster. So obviously, if numerator will be lesser, this value will be lesser. Right? So if this value is lesser, it means this point is being classified correctly. But if this value is higher, higher means what? Your distance from its own, distance from its own group. Okay. When it will be higher, when this value will be higher, it will be like when distance from its own group is more than the distance from the other group. Right? Distance from its own group is more than the distance from the other group. It means what? It is misclassified. Okay. So silhouette score is just the ratio between like how close a particular point is from its own, kind of a cluster compared to other cluster, right? So let's see, is an evaluation matrix for clustering that measures how well each data point fit into its assigned cluster and how distinct it is from the other cluster. It will range from -1 to 1, where values near to +1 indicate well-defined cohesive clustering that are far from the clusters with negative values suggest misleading point, right? And it is being calculated for each point and average to all and an average to get an overall measure of clustering quality helping access it. So formula is over here. Okay, this is a formula. So I just told you this higher level formula just to understand like the concept. Okay, like this is a, this is not the exact formula. This is just to understand the concept, right? Like we just try to calculate the ratio. The actual formula is like this. Okay, so it would be, if I just show you the formula only. Yeah, this is a formula. Okay, bi is what? Is a distance. This is the so when you calculate this distance, okay, distance between I and its next nearest cluster centroid, okay, that is bi. Okay, and AI is itself distance. So we calculate the difference between BI and AI. So if BI is higher, obviously this is positive. But in case if BI is lesser and AI is higher, okay, let's say I have this particular, this is green. Okay, let's say I have, this is green, this is green, okay, and this is yellow. So in this case, what is BI? BI will be this one, okay, and what is AI? AI will be this one. So in this case, BI is lesser, AI is higher. That means the distance from its own cluster, okay, the distance from its own cluster is higher than the distance from the other cluster. That means this point is misclassified. That means it is negative, right? And then we are dividing it by maximum of AI and BI just to normalize it in the range of -1 to 1. Okay, here the denominator is used just to normalize the Silhouette score in the range of -1 to 1. Right. So let's try to implement it over here and check what Silhouette score is giving me, right? So for that purpose, let's say, so this is your elbow method. Okay, and now let's say Silhouette scores. Okay. So I'll import from sklearn.matrix import Silhouette score. Right, I'll create the x is equals to dfc1.copy. I just don't want to disturb the actual data. Okay. Then same way I will create over here a list of things. So Silhouette scores. All right. And then I'll do what? I'll define, let's say for k in range. Now here it can be minimum k value. I can use 2. I can't use 1. Right? Because obviously minimum 2 clusters are required to calculate this ratio. With 1 cluster, this can't be possible. So here it will start from 2. Let's say I'm going to 12. Right? And the same process. Let me use model ST over here. Same model I'll not use it may because that model may have some memory. So now I can use number of clusters and then this one. Now we can use what over here? Model, or you can say model ST dot fit. What I have to fit? X. Right? And then when it fit, I have to calculate, I have to predict, right? So labels is equals to model ST dot predict. Okay. Make the prediction on the X. Right. And thereafter we have to calculate the Silhouette score. Because for calculating the Silhouette score, this predicted label is important. So here I have to feed what two things. One is called X, another is called labels. Right. So here I have my scores. And this score will just store this thing over here in the Silhouette scores. Okay. So when you are going for any kind of an interview or kind of, suppose discussion, technical discussion in unsupervised learning, generally it used to be a very important question that how do you decide the number of clusters, right? So elbow method is one of the way, but always try to give multiple solutions. Okay, you can say that using elbow method we can decide the some optimum number of cluster, but sometimes elbow method is not enough to decide. As curve becomes, because sometimes what happens, the curve becomes like this. Okay? Sometimes the curve becomes like this. So in this case, you can't decide, right? Sometimes elbow, the curve becomes so smooth that we don't find the elbow and all. So we also use the sellout score. So sellout score is something which represents the, kind of a ratio between how, or it represents how well a particular data point is classified or misclassified. Okay, if it is negative for a particular data point, that it is misclassified, but if it is positive, it is well classified. If it is close to zero, that means that data point is at the border, right? It's not the data point is at the border over here. Let's say some data point is over here, then sellout score will almost be zero, right? So now we can calculate the sellout score of all the data points, okay, by forming two clusters, by forming three clusters, therefore then forming four clusters, and then we can just plot it, right? So let's say plt dot plot, okay, range what 2 to 12, and then sellout scores. All right, marker also I can use. So maximum sellout score will be better because according to the formula, what is required? The difference between this thing, right? If I have a difference over, the difference between this thing should be as maximum as possible. This should be as high as possible. This should be as low as possible, right? So that's why. What happened? Hmm. Sellout score is maximum if I'm forming two clusters, right? Just a minute. Let me check X actually before going ahead. All right. So what is behaving differently every time? It's I'm doing something incorrect. All right. So sellout score is maximum if we have two or three clusters, right? That can be here also. It was saying the similar kind of things. Like after two, it came over here three, right? So here the maximum will be the good, right? So I can go ahead with the two clusters, but if I want lesser number of countries, right? So I can go ahead with the three clusters to help. So two or three can be the optimum value over here as per the this particular value, right? Every time it is changing its behavior. Am I doing something incorrect? Or every time it is identifying it, some data point is changing over here. What model st dot predict x fit predict, everything is fine, right? Uh, Let me just fix the random state. Actually, random state is equals to 0 because it is randomly every time. I just want it to be fixed. Yeah, then it's fine. Now I guess it will remain same. That's okay. So two or three is a good, right? So this is how we can decide the how many clusters can be good, right? So let's try to create a model. Let's say final country is equals to KMeans number of clusters. And since it is, unsupervised learning, there can't be any correct or incorrect answer. Okay, here just we try to find out the best possible solution. Okay, it may possible 4 clusters can also be good. It's not like that 4 clusters someone is creating it is incorrect. If you are creating a 4 cluster, then you should be capable of explaining those 4 clusters, that how all the 4 clusters are different from each other. Okay, 2 clusters should not have a similar behavior. The point over here is, if you're forming 4 clusters, that's good, that's fine. But you should be capable of explaining those 4 clusters. That means all 4 clusters should have different behavior. It's not like we form 4 clusters and they're having a similar behavior. No, right? So let's say here I'm forming 3 clusters. So model, country, dot fit, DFC1. Okay. Then I will have model. So this is done. Now from the center, so model, country, dot cluster centers. So these are the cluster centers. I can convert it to data frame. And I can give the columns is equals to dfc1 dot columns. All right. So here I can say that cluster centers. Okay. So now if you see, I am getting only these 2 things. What are these 2 things? Income and GDP. Why am I getting? Why am I not getting the other values over here? Because compared to these 2 value in the data, income and GDP, the others are having a very smaller magnitude. That's why after forming the centers, after forming the clusters, I can't, visualize them properly. So better we should do what? We should normalize it, right? Or scale the data. Right? We should do what? We should scale the data. That would be a good choice. Right? So let's see. DFC2 is, let's say I'll use over here from sklearn dot pre-processing import min max scalar. Scalar is equals to min max scalar dot fit DFC1 and scalar dot transform DFC1. Okay, so let it be DFC2. All right. So here also DFC2. Now let's see if I use a scale letter, then what happened? Then it is showing that 3 can be good choice. Okay. Here also let's say DFC2. So now here I'm using DFC2. Based on DFC2, if I'm trying to do this thing, so it is again saying that 2, then 3, then for the 4 it increases, right? So here some behavior is different, right? So for the 4, like obviously if it is 2, then only 2 groups, right? If it is 3, then sell out score is lesser, but 4 it increases, right? And here also 4 is showing some good point, right? So 3 or 4 can be a good choice over here. So let's say I'm forming just 3 clusters, DFC2, right? Cluster centers. So now I identified over here Okay. So here I have identified that we have three clusters. Out of these three clusters, child mortality is higher in cluster one. Okay. So it may possible that cluster one is concerned. Okay, we should be concerned about cluster one. Child mortality is higher, export is lesser, GDP is minimum. Okay, income is also minimum out of all these. Right. So this is a behavior of three clusters. Now you can also check the behavior of four clusters. Okay. So in the four clusters, you can see that the cluster one, okay, initial cluster one divided into two parts. Okay, this one and this one, right? But the difference over here is what? This is more, this thing is having a, more worse condition. Okay. No, sorry, not this one. This one. The cluster one was divided in two parts, cluster zero and cluster two. Okay. So here, this is having the more higher child mortality. Other factors are very similar apart from fertility. Fertility is also high. This one is also very low, right? So if I have to, help, so I will first give the preference to cluster two because cluster two is having the more, uh, the condition is more poor, right? And then once the cluster two I help, then I go for cluster zero. Say cluster two and zero are having a similar kind of behavior. Not exactly similar, but yeah, very close. Right. So cluster two, if I have to identify what I can do, model country dot predict DFC2. Okay. And this can be, let me define DF final is equal to DFC dot copy DF final labels. So DF final dot head. Okay. So now I can find out cluster two by using DF final labels double equals to 2. So this is what we have. Okay. So there are two process I told you to see, like now you can find out the country name over here, dot country. Okay. So two process I told you how we can identify or what are the process through which we can decide the number of clusters. It is silhouette score or elbow method. So by this we get a general idea that okay, 2, 3, 4 clusters can be a good choice. Right. So please have a look. Let me know if there is any questions over here. Right. And thereafter try to go for the next. I just wait for 5 minutes. Just allow me for the 5 minutes. Just go through the things. Okay. And then we'll try to explore more. Is it done?
Yes, sir.
All right. So next, we had seen clustering, how it works, and we had seen the score, that how you can decide the number of clusters and all. Okay, now let's say okay. So there is a clustering approach which is called hierarchical clustering, right? What is this? The hierarchical clustering. So hierarchical clustering actually works like this. Okay. So here what happened? First, each data point will be a separate entity. That means each data point will be its own cluster. Right? Now the algorithm will try to find out the two nearest data points. Okay, which are closest to each other, like this. Okay, and try to form a group of it, like this. Now it will go to the next level. Now the average of these this particular cluster, or the average of this cluster, this is alone the average. So now the average of this cluster is closest to which other average? Okay, like this. It will form a group like this, isn't it? Thereafter, this process will go again and again. Okay, like this, right? Over here. And then at the end, it will just combine into a single cluster. Now, based upon the structures that we get in this hierarchical clustering, we need to decide how many clusters can be good. This works in hierarchy. That's why it is called what? Hierarchical clustering. All right. Am I clear? So here, if you see, KMeans is done. DBSCAN, I'll explain DBSCAN as well. Hierarchical, I'm explaining first, right? So hierarchical clustering is all about creating a hierarchy for the cluster process. So let me just try to implement it over and create a new file. Okay, it is hierarchical. HEIE. Spelling is just a minute. All right. Now let's try to implement it. For implementing it, I'll take a data. Or what data shall I take? Let me take the same data, which is simple and easy to understand. That is a model data, right? And let's see how hierarchical clustering is behaving over there. Import numpy as np, import pandas as pd, import uh, what matplotlib dot pyplot as plt. Now df is equals to pd dot read underscore csv, right? And then All right. This is done. Now what happened? I have to just read those information that I want to use for the clustering. So df1 is equals to df age, annual income, and spending scope. All right. Now what we do, we'll try to see like how we can form the cluster. So for that, we'll just import few more library like this thing is called dendrogram actually. When you see this thing is called dendrogram. The linkage that you see, this is called dendrogram, right? So from scipy dot cluster dot hierarchy. This is here we are using the scipy library, not scikit-learn. Okay, this library we are using. Okay, scipy. Okay, so there are a few algorithms that exist in the scipy library as well. So for the hierarchical clustering, it is the library is over there. So import dendrogram, and there is one more thing I have to import, that is called linkage. Okay, because there are four kinds of linkage to create the hierarchical clustering, right? So first it is single linkage that will represent the minimum distance between any two data points to form the clusters. Like I told you over here. Where is it? Like I just explained, right? The minimum distance. The complete linkage is maximum distance between any two data points, that is used lesser, right? Then average is like average distance between all pairs of point. Okay. And then what method is what? Is minimizing the variance within the clusters. So these are the different linkage methods. Okay. These are the different linkage method to decide these two clusters, like how to group two data points. We have to use minimum distance, we have to use maximum distance between two data points, average, or what. Generally, what works better, because what is something which maximizes the variance between two different data points. So two different clusters. Okay, if two different clusters are having maximum variance, that means different clusters are representing different information, right? So that is why we import linkage. Okay, and then from sklearn dot cluster import agglomerative clustering. This is called agglomerative. Okay, and matplotlib already we have imported. That's fine. Now we'll define the linkage matrix. Okay, so Z is equals to, let me define over here, X is equals to df1 dot copy. So here I'll call the linkage function. Okay, feed X comma method. Method is what? Word method. Let's say Z. Right, so it will just find out all the linkages. Okay, like it is some data points. Okay, and then 2, then 3, then 4. It just kind of keep combining it. Okay, going from bottom to top. So let's try to plot this thing, this information. Right, so we'll just use PLT, or you can say plot dendrogram. Okay, so PLT dot figure I'll define over here first to set the figure size. Let's set figure size over here. What is the figure size? Let's say it is 12 comma something 8. Later on we'll see, like we'll just try to increase or decrease. Right, thereafter we'll call over here dendrogram, which is, let's say, Z. Thereafter PLT dot title. hierarchical, HIERARCH, hierarchical clustering dendrogram and PLT dot. So right. So it is what we are getting right. We can just put the X label and Y label also over here. Let's say PLT dot X label. That is your data points, and PLT dot Y label. That is your distances. All right. So as per this thing, it seems like 3 is good, right? Let me just decrease this figure size to 5. Okay. So now if you see over here, how do you decide number of clusters? First of all, by looking at these, groups, we can decide that, okay, 3 clusters can be good, or we can do what? We have to find out the longest streak which is not divided by any horizontal line. Okay. This is a line. Let's see. I'll explain you. See. Okay. See over here. Here, this is one of the line, right? This is another vertical line, but this vertical line, this guy is just kind of a cutting down over here, right? So this vertical line will not use, right, to decide the number of clusters. Okay. Then we have this thing. Then we have this thing. Okay. We have this thing. So if you find over here, compared to, compared to this line is not divided by any horizontal line. Okay. And this line is also not divided by any horizontal line. This one is also not divided by any horizontal line. Okay. Then it is not cutting. No one is cutting it. Okay. This one is also not getting cutting down. Okay. But this is longest. Compared to others, this is longest. Right. So, if I will I have to decide the number of clusters. So what people do, they just divide it from here, the longest one. Right. So if you divide it from here, then how many clusters will you get? See, here, this can be one cluster. Okay. This is other cluster 2. If you're dividing it from here, then this is 3, this is 4, and this is 5. Total 5 clusters. That means as per this information, using hierarchical clustering, 5 clusters can be meaningful clusters. All right. You can deep dive into it to check the other significance as well. Let's say if I will try to again now divide this thing. This one is also dividing. So based on it, I don't think this line should be considered or other line, So this one seems to be a longest, right? So hierarchical clustering can also be used to understand how many clusters can be there. So how we decide? Based on the longest vertical line, not divided by any horizontal one, right? So next, just form those clusters. So hierarchical clustering is equals to, all right. Here we define few parameters like number of clusters. That would be 5. Okay. Linkage we are using is word. Yeah. With the linkage also, it changes a bit. Like what are the 4 linkage I told you? The 4 linkage that I told you was, where is it? Single, complete, average, and word, right? So you can try that also. Let's say if I use single, okay, so it is not that meaningful over here. Complete, okay, this is a little bit more meaningful over here. So based upon different problem statement, different linkage is more meaningful. So you can just tune it and check which one is giving you the more meaningful information, right? Then average, okay, and thereafter word already we had used. So word and complete is giving you the more meaningful information. All right, and then I can do what? Clusters, or sorry, hierarchical clustering dot fit x. Okay, and then clusters is equals to hierarchical clustering dot predict x. Right, now I can just take the data. Let's say df labels is equals to clusters. Oh no, predict spelling is wrong. No, it's correct. I guess this thing don't work like this. Maybe fit and predict works together. Maybe like in this case. Anyway, let me check. Df dot. All right. So now you can just have the. We can just find out the significance of each cluster by grouping. Right. We can just do the grouping over here. Df dot group by. Okay. Labels. Right. And I can take the other columns over here. Isn't it? Okay. And then I can find out the average of it. Okay, so this can explain my significance of clusters. Right. Now, what is your assignment for today? Also, I'm giving you a short assignment, and that is very simple one. You have to apply the hierarchical clustering for the country data. Okay, so apply, use hierarchical clustering for country data. All right, and check the performance. Like, how is it different from the K-means clustering? Right, are you getting the similar kind of information, or it is giving you the different? Like here it is giving me different kinds of information. K-means had given me 6 clusters, here it is giving me what, 5 clusters. All right, so just here also we can go ahead with a 6 cluster. There is no such limitation. Okay, but that is our own, we can decide it like that. Okay, but here we are just kind of using these two things into one group. That's why it is forming a 5 cluster as per the general rule, that it is not a kind of a law that you have to use this line which is longest line to divide the whole thing. No, there is no such law. It is a general practice that people uses, and most of the time they get the correct answer. But in case if you are visualizing, and after visualizing you are finding, no, this is something which is giving me a value 5, but 6 can be the meaningful, so you can take your call. Okay, that I'll form the 6 cluster. Only thing you have to explain all those 6 cluster, that all those 6 clusters are different. It's not like that. They have some few are having the similar kind of information. Right. So based on this, just try to complete it. This will be the assignment for you. There is one more clustering technique that is there, which is called DBA scan. So in the upcoming class, I'll tell you about the DBA scan, right? And as well as I'll tell you about the association rule mining for recommendation system. That will take one more class to finish the things. Meanwhile, if you find anything which is not clear, please do let me know so that I can explain and make the things clear for you. Any question from the today's session? Please tell me.
No, sir.
All good? All right.
Yes.
All right. Thank you. Take care.